Okay, from the mixed review from Chapter 3, we're going to do probably one of the most difficult problems is number 56. Alright, so first we're going to read the problem. It says a golf ball with an initial angle of 34 degrees. So I'll write that down. In my given, I know that theta is 34 degrees. Lands exactly 240 meters down the range. So now I'm already seeing that this is the type of problem where it's a projectile where it's launched at an angle. And what I really need to do is, the first thing I need to do is draw a picture. So here's my projectile, VI. I know this angle here is 34 degrees. And it goes like this. That's the path of the projectile. Now, whenever I do projectile motion, I always want to separate my x and y given. So I'm going to have my x given, and I'm going to have my y given. The first thing I'm going to do is, in the problem, no matter what, on every single problem, I always know that ax is 0, and I know that g is equal to negative 9.8 meters per second squared. The next thing I do is I want to write take my initial velocity, VIX, and VIY. The problem with this is I haven't read the rest of the problem, but they don't tell me VI. Then I read the rest of the problem to see what else I know. So let me read the rest of the problem. So it lands exactly 240 meters down the range. So from where I start to down here, this is x. So in my given, I can write x is equal to 240 meters. So it says, neglecting air friction, what is the initial speed that would achieve this result? So that means that we want to find A, VI. Using the speed determined in item A, find the maximum height reached by the ball. So we want to find BY, which would be the maximum height. And remember, the maximum height occurs in half the total time. So we'll just put that aside for later. Now the problem here is we always want to start with where we have 3 variables. So we don't have 3 on either side. And another thing that we know is from where I start to where I end up, my vertical displacement is 0. So I can go ahead here and write that y is equal to 0 for the entire trip. The problem is I still don't have 3 things. So what you do is you just keep going through the steps. You don't give up and say, this problem's impossible, I don't know how to do it. That's not what you do. Okay, you start to think. So obviously I have to do something with this. I don't know VI, but they did give me the angle. So what I'm going to do is just off to the side, I'm going to say I know VI looks like this. And because I did learn how to do vector resolution, I know that this is going to be VIX, and I know this is going to be VIY, and I know this angle here is 34 because they did give me that angle. So I still don't know what VI is, but I can start doing maybe something with the angles. VIY is opposite, so it's sine. This one is adjacent, so it's cosine. So VIX is equal to VI times cosine of 34 degrees. And even though I don't know what VI is, if I take my calculator and I say 34 cosine, that comes out to be 0.829, so I'll say 0.83. So this is actually 0.83 times VI. If I do the same thing for VIY, this is equal to VI times the sine of 34 degrees, and this comes out to be 0.56 VI. So why did I do that? Well, now what I see is I have both variables in terms of VI. So what I'm going to end up doing is I'm going to have something called simultaneous equations. Now, I don't know what they call it now in math class, but we have two equations and two unknowns. Maybe they call it systems of equations. So if I have two equations and two unknowns, that's not physics. You do that in Algebra 1. So now this problem seems hard because there's, we don't have three things that we're plugging in. But everyone in here has the math ability to do this problem. So you just say, okay, let me keep working through my steps. So where should I start? I don't know. I know that VIX is equal to 0.83 VI, and VIY is equal to 0.56 VI. So I don't know. I'm just going to start with the Y and see what happens. Okay? So I'll start with my Y direction. And a lot of times I know that from here to here the vertical displacement is 0. And I have little g. I have VIY in terms of VI. I have Y. And I know I can usually find the time because I know the time here is the time here. So I'm going to do the same steps I did before. I'm going to say Y is equal to VIYT plus 1/2 GT squared. And I'll substitute in my values. 0 is equal to 0.56 VI times T plus 1/2 negative 9.81 meters per second squared times T squared. Now, we don't want to use the Pythagorean theorem. We don't want to use, I can't think what it's called. The quadratic equation, because we already have a bunch. We don't have T, but then we also don't have VI. So I'm going to factor out a T because we're only looking for the positive value of T. So I'm going to factor out a T. So I'm going to have 0 is equal to 0.56 VI plus, this would be minus 4.9 T. So then I'll move that what I'm going to do is I'm going to try and simplify this. So I'll move the 4.9 on the other side, and I'll say 4.9 T is equal to 0.56 VI. And then I'm going to rearrange this to solve for VI. So I'm going to rearrange this and divide this. So I'm going to divide 4.9 by 0.56. So I'll go ahead and do that. 4.9T divided by 0.56 is equal to VI. So VI is equal to 8.75T. So this is, I'm going to call equation 1. So my two variables are VI and T. Now what I'm going to do is I'm going to do my X stuff in my X direction. So I have AX is 0, VIX is equal to 0.83 VI, X is equal to 240, and I just found out that VI is 8.75 T. So remember, X is equal to VIXT plus 1/2 AXT squared. AX is always 0. So X is equal to VIXT. So X is equal to VIX, which is 0.83 VI, times T. But I already know here, if you look, see VI here? I can take this value of VI and substitute it in here. So I can say this is equal to 0.83. Oh, I know X is equal to 240. So 240 is equal to 0.83, and instead of VI, I'm going to write 8.75 T, and then times T. So does everyone see I took this, substituted in here? How many variables do I have now? 1. Can I solve this? Sure I can. So 240 is equal to 0.83 times 8.75 T squared, and then just multiply that out again. So when I do all that, my total time, T, is equal to 5.75, which we'll round to 5.8 seconds. All of this is the same physics we did before. The only difference was I had to do 2 equations and 2 unknowns. So a lot of you, after you, up here, you would have gave up at your given. But you see, if you just go through your same steps, you can end up getting an answer. You don't give up, you just go through it. Now, we haven't even found anything we were supposed... Oh, we have to find VI. So I can either take this equation or this equation to solve for VI. So I'll just do this one. So VI is equal to 8.75 times T. So it's 8.75 times 4.8 seconds. So VI comes out to be 50.75 meters per second. Part B said, now the problem's easy, because I could go back and put VIX and VIY. So now it says, what is the maximum height? So remember that the maximum height occurs in half the time. So if you look at your picture, the maximum height occurs here. We're solving for this y, which is going up, and this occurs in half the time. So now to do this, I can use that same equation, y is equal to VIYT plus 1/2 GT squared. I have to find VIY. So let me go ahead and find VIY. So VIY, it's 0.56 VI. So 0.56 times 50.75. So VIY comes out to be about 29. So this is going to be 29 times half the time. So I take 5.8 and I divide by 2, and that's 2.9 seconds. Plus 1/2 negative 9.8 meters per second squared times 2.9 seconds squared. And don't forget to square that. People always forget to square that. So that's going to be 81 minus 41, and this comes out to be 40 meters is the maximum height. So this problem, as far as the physics is concerned, it's not any harder than any of the other problems that we did like this for a projectile at an angle. The difference was the math. So we had 2 equations and 2 unknowns. We used basic algebra that we learned in Algebra 1, okay? And we just keep going through, and the problem really isn't that bad, okay? And that's it.